Hello, thank you for joining us. So, as Alistair says, I'm Adam Parks. I'm the technical lead at Jacobs for our digital flood products that includes Flood Modeler. But probably more importantly, I've been an active user of the software for well over 20 years. From my first job after leaving university, it was one of the first bits of software I was introduced to, and I've been using it ever since. So I think this is a good time to have a look at the past, present, and future of Flood Modeler. Where's it come from? How has it evolved over the years? What does it look like today with all the latest features we've added into the current release of Flood Modeler? And then spend a good bit of time looking at the future. Where are we going? And this is all informed by you. So at the end, we're doing the questions. If there's something you want, if there's something that frustrates you, please feel free to pop it in the chat, ask a question. And we've also have a QA link to a form where you can give us some further details. So really, we need your input to make sure we can carry on adding the features and tools you need. So Flood Modeler has been the mainstay of flood risk management for decades, and we'll see that in a second. And many generations of modelers have moved from using it as new starters, progressing to professional, confident users, and then moved on to teaching the next generation of users. And as our user base has expanded, as the number of roles in which Flood Modeler is used have expanded, so has Flood Modeler. It's added new features, new functionality to keep pace with the demands of our users and also anticipate what future needs look like. I've broken this presentation down to 3 sections. It's obviously just after Christmas, but I think we can still do past, present, and future. So past, we're going to have a look back at the evolution of Flood Modeler, where it's come from, how it's changed over the years, and also throw in a bit of light nostalgia for those who want to indulge. The present, so what can you do in Flood Modeler today? And what I'll be doing here is focusing on some of the major new features that have been added over the last 18 months or so. Some of these you may not be aware of, some of you may have heard of and don't know exactly what they do and need a bit of further information to explore them yourselves. So hopefully that will give you an encouragement to go and try some of these new features and get the benefit of some of the major improvements to Flood Modeler. And the future, where are we going over the next 12 months? Where are we going over the next few months? So as we come around to releasing version 8 in the next few months, this is going to result in some significant changes to Flood Modeler, and we really want to talk about these, show you what's coming, both in the first release of version 8 and then subsequent releases as we build on the new foundations, and that's really exciting to show you. So if we start with the past, where has Flood Modeler come from? This is one of my favorite graphics to use. So this shows the history of Flood Modeler over the years. I don't think there are many people who've still been using it since the 1970s, but Flood Modeler started as an internal piece of software at Jacobs, then called Halcro, called Onda. So this was a tool designed and used internally to answer some of the questions that engineers had. All the way back then, Jacobs was still a major provider of flood risk management services, and people were asking questions about river flows, about water levels, to design flood defences, to flood map. And this was all done by hand. So Onda was developed in order to allow a more complex and more detailed analysis of flood to be undertaken. And this is the basis of the 1D river engine within Flood Modeler. That was used internally for many years and eventually was released as an externally facing product in the early 1990s. Now called 1D River, but at the time called ISIS. And it took off really quickly. So it became the preferred solution for modelling flood in the UK, used by various government agencies and consultants, being adopted into the National Flood Forecasting Service and now becoming the primary river tool within IMFS for flood risk modelling. And since then, there have been some really significant improvements. In the mid-2000s, which is about the time I started work, we added two-flow integration first. That was the first integration with a third party, allowing you to dynamically link a flood modeler model to two-flow. And that was all the way back in 2004, 2005. And shortly after that, we added in our 2D engine as well. And so that allows you to undertake modeling in 1D, 2D, or linked using different interfaces. We were acquired by CH2M back in 2011, and shortly after that, we released what is you're now seeing as Flood Modeler, so the user interface you're all familiar with at the moment, and rebranded away from ISIS, which was somewhat problematic. Jacobs took over in 2017, but we've continued to build, significantly invest major sums into flood modeling. We introduced our first cloud compute back in 2018, now evolved into flood platform. We've continued to add integrations. This is a key part of our way forward, to work with other suppliers to make your life easy, not just in the flood modeling space, but associated areas of work. So we added swim integration back in early 2021, allowing you to build subsurface urban networks using the 1D swim module. We released our 2D GPU modules shortly after that, and that allowed us to start using 2D models in the National Flood Forecasting Service. In recent years, we've added further integrations, including the likes of Fathom, bringing global flood maps to your desktop. And over the last year, we've been working really hard on Hydrology Plus, which released as part of version 7 of Flood Modeler. This, working in collaboration with Wallingford Hydro Solutions, brings a full hydrological workflow to Flood Modeler. So from start to finish, you can undertake your flood risk assessment, your flood mapping study, all within Flood Modeler, from your hydrological analysis using WinFAP and RFH, integrated into Flood Modeler all the way through. And 2026 we'll be releasing version 8 of Flood Modeler, and I'll talk a bit about that later on. And just for nostalgia, this very much mirrors my career with Jacobs and other companies. So I'm not going all the way back to 1975, but in university back in 2003, I started to use Flood Modeler and flood software on a hefty CRT monitor, looking far more sprightly. Working for Halcro as it was on modeling, and very excited to get 2 monitors. That was a battle. Having started as a graduate and starting to learn how to use the software and understand flood modeling, starting to move into delivering technical training. So I don't know how many training courses I've delivered over the years, but I always really enjoy teaching new people how to use the software, both within Jacobs, clients of Flood Modeler, users of Flood Modeler, end users and suppliers. It's always really exciting. I enjoy still doing that. As a Flood Modeler, the current version, the current user interface was released back in 2015, has been enhanced ever since. Cloud computing back in 2018 signaled the end of this sort of arrangement. So for many years, we had lots of computers in offices, all wired up in different ways to give us the capacity we needed to run simulations. Things like Flood Platform would replace that, and certainly within Jacobs eliminates it to the point where we can do everything now through a web browser. Touring our offices, it's often nice to come across our old merchandise. So I was up in Glasgow the other week and came across one of our Flood Modeler mugs, which was nice to see still in circulation. And as I say, now increasingly, it's the next generation of modelers. So starting to use our software, starting to use our tools and take over. And they expect new things, they expect better functionality, and that's what we're striving to give them. And just before I move on to the present, just to look at how Flood Modeler has evolved. So this was what Onda looked like. This was what people were using back in the 1980s, a text-based interface. If you look really carefully, you can probably see some things that look familiar. We've got rivers, junctions, Bernoulli losses in there. Some of the same units you can still find in Flood Modelers, the sort of the underlying foundational units. This is the version of Flood Modeler I'm probably I started my career with and started to learn how to build models. Very 1990s user interface, lots of blocks you could move around to build your 1D model, not very GIS compatible. And this is the version of Flood Modeler we're currently using, with GIS at the center, still retaining the 1D components, but with ribbons and other modern UI elements. And I'll show you what this is going to evolve in at the back end of this presentation as we move away from that interface, we update the underlying technology and make it far more user-friendly. So moving on to the present, what I'll be showing you here is really what the current state of Flood Modeler is, perhaps touch on some of the tools and functions you may not be aware of that have been added in recent years, and perhaps encourage you to make some use of them. We've added a lot to Flood Modeler over the last 18 months. Key things include Hydrology Plus, data integrations I mentioned with Fathom, Environment Agency, SEPA, and others. We've updated the damage calculator tool. We've updated our licensing model, introducing cloud licensing, giving you a lot more flexibility on how you access the software. We've added the first of our new integrated units, the Super Bridge, which I'll talk about in a minute, as well as other tools such as Sim Builder. And these are some of the bigger chunks of improvement that have been made. There are hundreds and hundreds of other improvements and additional bits of functionality that have been added in the last 18 months. I've only got 10 minutes or so to talk about some of these, so I'm going to pick on some of the big ones. So I'm going to look at the Hydrology Plus integration and also look at some of the new integrated bridge units and what they look like and what they'll allow you to do. Hydrology Plus is something I was really keen to make happen when I joined the flood modeler team. I've been a hydrologist and modeler for 20 years, and it's always been a point of frustration for me how disconnected the worlds of hydrology and modeling are, particularly on larger consultancies where you often get badged as a hydrologist or a modeler and you don't meet in the middle. I've always enjoyed doing both. I think if you're understanding flood risk, particularly in the UK, you need to be able to do both hydrology and modeling to fully appreciate what's going on. Although UK hydrology is well developed, we've got the very well set out flood estimation handbook, FEH, and the tools such as WinFAP and RFH to undertake your analysis. It's always been frustrating how disconnected it can be. You have to go and collect your data, you have to download it from different websites, from UKCH, from NAFRA, from EA, from SEPA, from NRW. You're holding it in spreadsheets, and then you're putting it into software like RFH and WinFAP and constantly moving things around and reconciling it at the end. And once you've finished your hydrology, either you've done it yourself or the hydrology colleague has done it, you then have to convert it into the right format to feed into Flood Modeler or whichever software you're using. And it's always felt that it was needlessly complex. And so Hydrology Plus comes from that point. We need to make it easier for people to undertake hydrological analysis, to join everything up and really reduce the amount of manual effort required. Easily 50% of the time you spend on a hydrological analysis is manually moving data around, converting things in Excel spreadsheets. If we can remove that overhead, you can spend more time improving your hydrology, improving your analysis, and getting better outcomes rather than paper shuffling. So we've partnered with WHS to make this happen. You can now access WinFAP and RFH through Flood Modeler. And you can also access the software licenses directly to our cloud licensing, which is a really great improvement. We've introduced a hydrological database allowing you to store all your hydrological data within Flood Modeler and giving you instant access to the latest data. And I'm going to show you all this in just a second. You can manage your catchment descriptors within Flood Modeler. We've integrated the Wonderful software, and we've got the full hydrological workflow from data collection through WinFAP and RFH analysis, hydrograph scaling and reconciliation, climate change analysis, and at the end of the day, automated report building, which we're continuing to improve, as well as direct applications to the model. So what does this look like? When you open Flood Modeler, you can access Hydrology Plus directly within the interface, and it's all built in from where you go. Say, eliminate a need for spreadsheets, data requests, and manual processing of data. So really saving you time and effort. Within Flood Modeler, you can access your catchment descriptors live within the software and create new projects. You can see there you've got your catchment descriptors already brought in, and you can store thousands of catchment descriptors you may have purchased from FEH Online. You can review the data associated with these catchment descriptors and these gauges live in the software, automatically bringing in the data from remote sources. This speeds up your analysis dramatically. You can start a new analysis by creating a calculation point. This is a flood estimation point. And from there, the user interface takes you step by step through a hydrological analysis, starting with a review of the catchment, a review of the catchment descriptors, and then finally moving on to both WinFAP and RFH analysis, at which point you jump into the right software automatically. And once you've completed that analysis, it gets brought straight back over into Flood Modeler. So you can see all your hydrological analysis directly in Flood Modeler. You don't need to go out. You don't need to paste things into spreadsheets to create plots and charts. It's all done in the software. Once you've completed your analysis, you can reconcile it, so you can scale your hydrographs to your statistical peaks. You can apply climate change all within Hydrology Plus and apply it directly to a model. So it really is a huge saving of time. If you've not tried WinFAP or RF8, sorry, you've not tried Hydrology Plus within Flood Modeler, please have a go. We've got lots of information on our website. There's some great knowledge-based articles. It will save you a huge amount of time, and we're going to continue to improve that throughout the rest of this year. And if there's anything you need, please do let us know. The other major change is the introduction of our integrated units, the super units. You saw earlier that some of these units have been in Flood Modeler for a long time, things like bridges, weirs, orifices, culverts. These are fundamental hydraulic units. We've not changed the hydraulics underneath these, but what we've done is recognizing they're not as easy as they should be to add to your hydraulic models. If you're modeling a bridge, you may need to have several components, the bridge itself to get the openings, a spill to represent the decks, perhaps a flood relief culvert or two, plus connections up to all the other units around it. You could be adding easily 10 different unit types in Flood Modeler to represent one structure. The intent behind integrated units, the first being the bridge, is to reduce that, again, to make your life easier. So the first of these integrated units, the super bridge, is in version 7.3 of Flood Modeler. It brings together all the components you need to build a bridge in a refined user interface. We've also updated some of the parameters and the settings within the unit to make them more realistic and respond to user feedback. So again, what does this look like? So if you've got your model, you've got your cross sections, you want to add a bridge. With the super bridge, it's really easy. You just select the bounding cross sections, the up and downstream cross sections, and click Add Bridge Unit. And that automatically adds the bridge unit and does all the linking for you. I've not cut anything out of this demonstration. This is all you need to do. Literally choose your units, click Add, and then start describing it. As you see, you automatically brought in or connected to the up and downstream cross-section data. You don't need to copy and paste cross-section data in it. You can override it if you choose to, and then you can define the openings. And this automatically updates on the right-hand panel, so you can see what your bridge looks like as you add those different openings. In this case, this is a USBPR flat deck structure with two spans, two openings. And then, as with Hydrology Plus, the user interface takes you through the process. So once you've added the openings, you then add the spill. So that could be a spill over the deck or spill around the outside of the structure. And again, you can add those directly in Flood Modeler, and the user interface updates the schematic as you go, so you can see exactly what you've got. We can also add blockages. In this case, I'm not adding one in, but it's easy to add a blockage here rather than adding another unit. And relief culverts as well. We've updated the relief culverts, so these now use the orifice equations. And you can quickly add these in, as many as you like. And again, they're represented on the screen, so you can at a glance see what makes up the unit. We've rationalized the parameters so they're more consistent, and we've put some tighter bands on what parameters can be accepted to make them more realistic. Once you've done that, it's done. So in literally 30 seconds, you can add a bridge structure into your model rather than taking a lot longer to do it the old manual way, hopefully making the experience a lot better. And when you come to review these models, it's a lot more obvious what's going on at that structure. Another nice thing is when you look at the results, rather than having lots of different units to look at, the spill, the bridge, and so on, they're unified in one place. So on this plot, we've got the total flow as the big hydrograph in red at the top. We've then got the spill flow in green below it, and then we've got the aperture flow, the flow through the bridge in orange. And it's immediately obvious at what point the flow started going over the top of the structure, when it ended, what the proportion of flows were between the aperture, between the relief culvert and the spill. And so again, it just makes your life easier. And the intent is we're going to carry on with these units, these improvements across Flood Modeler as we add more and more integrated super units. And I'll show you some of those in the future as well. Those are some of the two of the bigger changes to Flood Modeler in version 7, and certainly Hydrology Plus is a really major improvement. We're often asked about benchmarking, about do I get different results from using newer versions of Flood Modeler? And we're often asked for older versions of the software to run old models. Just a point on that, whenever we release a new version of Flood Modeler, we do extensive what we call regression testing. We want to be confident that the results you get from Flood Modeler haven't changed because of the changes we've made under the hood, or the change are intentional. So whenever we release a new version of the software, we rerun dozens and dozens of models, lots of simulations, and check the results, how they've changed, how long they take to run, what the results are. And we never release the software unless we're confident that the regression testing has been passed and any changes in the result are as intended and improve the quality of the result. One activity we've been doing recently with the Environment Agency is looking to update the National Flood Forecasting Service from version 4.6 of Flood Modeler up to 7.3. And obviously the performance is essential in the forecasting service. So we've taken just shy of 500 Flood Modeler models from the National Flood Forecasting Service. We've taken a month's worth of rainfall, both a dry month and a wet month, and we've rerun all those models against Flood Modeler 4.6 and 7.3. And what we found is the results are identical between the two of them up to 6 decimal places. So they are giving the same result, whether you're running 4.6 or 7.3. And that's incredibly reassuring. That's exactly what we wanted to see. We also see that the model run times are the same. So we're not seeing any, despite all the additional features, all the additional units and computational elements being added, the models are still running in the same time period. And we'll continue to repeat this this analysis every time we release Flood Modeler. So just to reassure you, we're adding a lot of functionality, but you can be confident you are getting robust results. And if your model doesn't run in a newer version of the software, there's usually a good underlying reason about setup or advanced parameters, and we're always happy to help you with those. So that was the past, 1975 till today. The present, what we've done in the last year or so, all the new features we've added. Let's have a look at the future. What are we doing in the next few months and the next few years? We've reconsidered our design philosophy for Flood Modeler. A lot of the time with technical software, it can become very complex very quickly with lots of features not as well presented or accessible as they should be. So our design philosophy is that our software should be intuitive and simple where necessary. It should be forgiving. So if you do make a mistake, we help you correct it. We're not going to crash the software on you. We're not going to give you obscure error message. We want the software to be forgiving. It should be familiar. We don't want to make changes so radical that people can't find their way, and hopefully you'll see that shortly. It should be modular, so we can add new components on, add new collaborations on, fast and precise. And the software needs to meet the needs of new entrants to market, so early careers people, early careers modelers who are just starting. They can find their way around and use the software intuitively, all the way through to those with as much grey hair as I'm gaining, who've been using the software for decades and really need those power features, those very bespoke bits of functionality. So what we've been doing for the last few years, in the background, as well as releasing 7.3, we've been making some really significant changes to Flood Modeler. As you saw, some elements date back from the 1970s. We're using code, including Fortran, Delphi, and others. We need to update some of this so we can make this interface more modern and we can make the software fit for the future. We've been moving a lot of the code from Delphi to C#. And as part of this process, we've been reviewing and updating all the units, all the run forms. So those forms you see pop up when you open a unit, they've all been reviewed. We've extended the functionality. We've improved the functionality in many areas. We've improved reliability. And a key thing is, by transitioning to a more modern code base, we've got a larger developer base who can help us further expand and enhance the software. This is a really important move. And it's also allowed to do things we wanted to do for a long time, and I'll show you that in a minute. Another key thing we've been doing is upgrading the GIS. We first introduced the GIS components into Flood Modeler in 2015. At the time, it met the needs of our users, but files are getting bigger, GIS datasets are getting bigger, 2D models are getting bigger and more complex, so we needed to overhaul the 2D. We've replaced the 2D module underneath Flood Modeler, and this will be released in version 8. And the intent is it loads far larger data files far faster and more reliably. It supports evolving range of GIS formats, COGS, geopackages, and so on. Importantly, it's got better projection handling, particularly when you're bringing in global data sets and you want to map them against local data sets. They're often in different projections, so we need that transformation to be really accurate, and that's improved dramatically. Faster web mapping, when you're pulling in background mapping or background data sets from WMS, APIs, and so on, you want that to be fast, and that's what you're getting with the new release. It includes some very advanced caching features, so once you've got your data in there, you can pan and zoom around effortlessly. Although it won't be in version 8.0, we are going to add a new 3D viewer as well to allow you to understand flood risk in a 3D environment, and that's enabled by the new code and the new GIS. And we're also spending a lot of time now ahead of the release improving the styles. So when you load data in, it's automatically styled in a way that makes sense. If you load some LiDAR in, it looks like this. It looks nice. It's got hill shading. It's got the right color ramps on it. If you load in flood results, they're styled to look as you need them to be. We don't want users to have to spend time changing the defaults every single time. We can detect what sort of file you're loading in and apply the appropriate styles. So I showed you earlier what the evolution of the software looked like from Onda to ISIS to Flood Modeler. What's version 8 going to look like? So hopefully familiar. So version 8 of the software will look very familiar to version 7. We've kept the ribbons, we've kept the panels, we've kept the broad layout, but everything has been recoded in a new code base and rationalized at the same time. So it'll look fresher and more modern, as well as retaining that familiarity and improved intuitive interface. One nice thing we're able to do now, we've updated the code base, is to implement a dark mode. We spend an awful lot of time staring at our computers doing hydraulic modeling work, and lots of people prefer to work in a less brilliant white environment. So we couldn't do this before we updated the code base. We can now rapidly switch between light and dark mode on your desktop. I was really excited about this. It was a great improvement. The other thing we've done is we brought the project back into the focus of the software. So when you start a new model, when you open an existing model, you're invited to update all the project details. And the reason for this is we're seeing significant issues about moving models around. So if you worked on them in your own company and you want to move it to another modeler, if you're giving it to a client or giving it to an end user, lots of key data is lost along the way, and we want to capture all that. We want the hydrology data, the modeling data, the input data, everything to go with it, as well as the overarching metadata. So when you start a new project, you're invited to define that project, give it a description, what sort of model it is, 1D, 2D, fluvial, coastal, etc. And the data you put in here helps configure the software. So if you're building a 1D model, we'll put prominence on the 1D build tools. If you're building a linked 1D, 2D model, we'll make both 1D and 2D and the linking tools available. If you want to do an urban model, then we'll make the swim tools available. You can switch them all on manually, you can change this, but again, it's about focusing the units and the tools on what you need to use. Again, a nice thing we're able to do because of the changing code base is to unify the search. There are hundreds of tools and buttons in Flood Modeler as it's evolved over the years, and it's often been hard to find them all. With the new unified search, if you want to find something, say a labyrinth weir, and you can't find it in the user interface, you just simply do a search for it. If you want to find damage calculator, do a search for it, and then you can add it to your favorite. So everything can be found in a few clicks. Again, this comes back to that familiar point. We are changing how this looks and where buttons are, and people will be familiar with how they used to be. We want to make it as easy as possible to find stuff, and that's going to continue. We've reconsidered where all the menus are. So under every menu, we've gone through each and every menu and reconsidered what's in there and what needs to be in there. So as part of this, we've got the new tabs along the top, which cover general software elements. So general, model settings, the UI theme, dark or light. The project allows you to open a new project, edit the existing project, export that project, so you can bundle up all your data, your reports, your hydrology data, everything, and send it off as a single package. Layers allows you to access existing layers or create new layers or add them from a data library. The view edits what panels and tools you see in here, and again, that's reactive depending on what sort of model you're building, but you can also manually go in here and switch things on and off as you need to. Switching on and off windows. And a key thing is the toolbar. This, as we've accumulated hundreds of tools over the years and the toolbar's been refined, we've remapped everything so it's easier to find either through the search or directly through the toolbar. And we'll continue to update those tools and add new ones. When it comes to model build, we've got a range of new ribbons and simplifications in here. As we're adding these new integrated units, you don't need 5 different bridges or 8 different weirs. We've got the unified weir unit, we've got the unified bridge unit, so we can simplify the ribbons for both the 1D flood modeler and the 2D flood modeler. For two-flow, and I'm not going to talk much about this because it's coming later in the year, we've got the two-flow integration. As part of this, you can edit your two-flow models live in Flood Modeler. So we're going to have a text editor built in, which allows you to do everything in one place. You have your Flood Modeler, your two-flow models in one place and edit them, not having to have separate Excel or notepads open in the background. We've got the 1D Urban. This is going to see a modest overhaul in version 8, but we're going to do significant changes in version 9 to the 1D Urban component. Hydrology Plus I've talked about, as well as our simulation tools. Results is worth pausing on. This is going to see an update as well, particularly the 2D results. At the moment, when you load 2D results in, it's all bundled up in a GIS window on the left-hand side. When you load 2D results in now, it's going to get its own panel on the right-hand side, which is a lot more intuitive how to use. It's got the unified navigation bar down the bottom, allowing you to move through the 1D and 2D results in sync and choose the sort of 2D results you want to see. And again, we're applying detailed, accurate styles to each of these. It just makes your life easier, and that's a really massive improvement. And combined with the new GIS, we can load far, far larger 2D results faster than you could before. Mapping tools are improving, so the background mapping and bringing in different mapping sets continues to be really important. So we'll have access to the current ones, the OpenStreetMap and the Azure Bing Maps, as well as a range of different global mapping sets as well. And a nice thing about the GIS change is we don't see projection artifacts anymore. Sometimes if you brought in non-UK reference data sets, you'd see a bit of an offset because of the projection transformation. That's all now gone, so the mapping looks an awful lot nicer now in Flood Modeler. We're adding a range of new structures. I've talked about the bridge already. I'll talk about the weir in a minute. 8 will also include the new integrated junction, integrated lateral connection. And future releases, 8.1, 8.2, will include a new spill and reservoir connector and our new leaky dam unit. So that's a natural flood management unit. Just show what the junction, the weir looks like. This is really nice. This is from the beta version, the software we're currently trialing. As with the bridge, you just choose your bounding cross sections, and then the unit is automatically added and connected up. And the really nice thing is this combines all the different weir types into one integrated unit, and it's a far simpler user interface. When you can choose the type of weir you want, and the interface responds to it. So change from a broad crest weir to a sharp crest weir, or to a general purpose weir, or to a crump weir. The user interface responds, and you're confident you've got the right one. It's automatically bringing in data from up and downstream. So all you need to specify is the crest of the thing, and the P1, P2 values are all automatically calculated. It's a far nicer unit to work with than the previous ones, and it makes it a lot faster to swap between different bridge units in the software. And this will be the same premise with the lateral spill, the junction, and the reservoir units as well. It's all about simplification and a nicer user experience. Conscious of time, so just to wrap up, the other major thing coming in version 8 will be the 2D Flex engine. This won't be an 8.0, it's likely to be an 8.1. We've been working on this for 5 years in collaboration with Southampton University to replace the existing ADI and TVD units. This is a finite volume solver, so it's inherently mass conservative, so a lot more stable. It'll enable quad tree and subgrid sampling, so allowing us to maximize the detail in our models and minimize the computational effort through both the quad tree, the subgrid sampling, and the compartmentalization of the 2D engine. And it'll be supported by a reimagined 2D workflow, which I'll talk a lot more about in a separate webinar. We're currently working our way through the final benchmarking. So as with the 1D engine, I talked about that regression testing. We do the same with the 2D. We're running a wide range of test models from the Environment Agency, from FMA and other sources. to make sure we're happy with the performance of this tool, both in terms of the hydraulic performance and the speed. So far, the results have been absolutely outstanding. We're getting some really good results, even in subcritical and supercritical flow, rapidly changing boundaries and shock capture. So we're more than happy with the results coming out of this. We will publish them all. We're just finalizing our final GPU tests now to benchmark it against different GPU engines. And after that's complete, we'll look to publish the results online so you can see how well this is performing before we release the software. A key element of the new 2D Flex engine will be the ability to support quad tree, so varying cell size within a single domain. Several other solvers do this already, but one thing we'll be adding is the ability to do that dynamically and automatically. So our AI mesh tool can sample your model and work out what the best mesh is for you to use based on land use, on boundaries and terrain. So just show you what that will look like. On this example here, this is a site in the north of England where you've got some artificial features, some canalized rivers, as well as some rapidly varying terrain. If you were setting the cell size of this model, you want to be able to do it reflecting that. So you've got a spectrum. You could start off on the far left-hand side with a really coarse cell size, say a 60-meter cell size, all the way down to a 1 meter cell size on the right-hand side. That's going from 100,000 cells to 25 million cells. You need to find the sweet spot in the middle, and that's what AI Mesh helps you to do. By sampling the underlying data, the software can give you options as to the level of detail you need in different areas. So you change the resolution of the mesh in different areas depending on what your needs are, and this is done automatically. The user can set the refinement strength, and then you get a range of options as to how fine you want to go. You don't need to draw lots of boxes to define this. The software does it in the background, and you can save easily 60 to 90% of your cell number of cells you need for a given model by taking this approach. So your models are more accurate and run faster, as well as being faster to set up. This is part of the overarching 2D workflow which we're introducing, and as with Hydrology Plus, we want the concept to be you open the software and everything you need to do to build your 2D model can be done in one place. You don't need to go to websites, you don't need to use other software to convert things. Everything is done in one place. You get a unified workflow which records what you're doing and documents what you're doing, ultimately making your life easier and making it faster to do your work. That's all I want to talk to you about today. I've obviously covered a lot of ground throughout that. As I say, we've got some time for questions, which Alistair will oversee in a second. If you have got any suggestions, if you want to see things in Flood Model that aren't currently on our roadmap, there's a QR code there. Will take you to a really quick survey. Just what do you want to see? We always want to hear more back from users. We get that feedback at webinars, at conferences, and engagement with our clients. If there's something burning you want to see, or some niggle you want resolved, please feed it back.